Okay, this question asks me to find a range. Okay, what does that mean? The range is a set of values we can get out of a function. Okay, the domain of this function is given here. The x belongs to r bit. This is the domain. That means I'm allowed to put any real value of x into this function. I've got to work out what kinds of answers I can get to the 3x squared. So there are two ways to do this. Okay, there's a way that just involves your knowledge of the x squared function, and it's in an algebraic way. And there's another way that uses a graph, and it's good to understand both ways to do this. So, the algebraic way, okay? So what do I know about the answer to x squared? I'm allowed to put any value of x into this. What values can I get out? Well, one of the first things you learn about the x squared function is that you can get positive values out, you can get 0 out, but you can't get negative values out. So the answer to x squared is always greater than or equal to 0. We want to know about 3x squared. But if I know this, then obviously 3x squared is also going to be greater than or equal to 0, and that tells me the answer. I can get out all values greater than or equal to 0. So the answer is going to be that f of x, okay, is greater than or equal to 0. So when we describe a range, then we always have to use the symbol f of x, or whatever the name of the function is, okay? We mustn't say x is greater than 0, because x refers to the inputs that I'm putting in, f of x refers to the outputs that I'm getting out. Now I said there was another way to do this. We know what the graph, y equals 3x squared. So when I set up a graph, the output of the function is y, and the input is still x. So now I think about x and y on the graph, and I know the graph of x squared is just a parabola, and 3x squared is the same. Okay, why is it the same? Because it is a vertical stretch factor 3, because this is times 3 outside, so I can work out using transformations what the graph looks like if I don't just know it. Or I can lob it into my graphical calculator if I've got one. Now this is the origin here. So how does this graph show me about the range and domain? Well, the domains are the x values I can put in. So it doesn't matter which point I choose on the x-axis, I can always put that into the function and find a point. So if I choose this one, there will always be a point for that value of x. Doesn't matter where you go on the x-axis. But for the y-axis, it's a different story. If I choose a value down here on the y-axis, there is no part of the graph that actually corresponds with that y value. If I draw y equals that value, which is a horizontal straight line, it never intersects the graph. The only bits of the y-axis that actually correspond to bits of the curve are these positive bits and this bit here at 0. So all of these points on the graph, okay, if I find their y-coordinates, I only get this part of the y-axis up here. I never get this part down here. So this is again telling me that the answers I get are the bits of the y-axis where y is greater than or equal to 0. And of course this f of x is the y. But we still write the range in the form f of x greater than or equal to 0. Okay, so that's what we mean by the range of a function, and we can now look at some more examples. For example, here is the same function but with a +2 on the end. So I would suggest that, I may do a video of this one, but you have a go at this one. So backtrack over what we did when the +2 wasn't there and think about how your answer for the range is going to change because of that +2.